Okay, so here's part 2. 5-3 exponential functions part 2. Alright, given the data table below, form an exponential function for the data. So here's t, probably in hours or something, and here's p of t, the amount of whatever you're talking about. You know, the amount of kilograms of some substance or weight of some substance. It could be anything. I just have the table here. All right, so let's talk about this. We know we need an exponential function. How are we going to find one? Well, we're going to look at the table here. How much time goes by? 3 to 9. That would be a grand total of 6 hours. I'm going to note that there. 6 hours go by from 3 to 9. And what happens to the amount? 260 times 3 is 780. It takes 6 hours for P of t to triple. That means that B is 3, guys. That means B is 3 because it tripled in 6 hours. Well, wait a minute. That means K is what? How long did it take for B to happen? How long did it take for B to happen? Oh, it took 6 hours. So K is 6, B is 3. Remember, we're trying to write a function that looks like this. A of t equals AB to the K over T power. A naught, I should have put there. Well, I got K. I got B. I need A naught. What could it be? What does A start out as? In other words, I need to know what A is when T is 0. When it started, when T is 0. Question mark, A naught. Well, let's think here. Let's write everything I got so far. Remember, instead of A of t, I'm going to use P of t. So P of t is equal to A naught B T over K. What is P of t? I don't know. Tell me what I know. I don't know A naught. I do know B. What's happening to A? It's tripling. How often? Oh, every 6 hours. Every 6 hours. I need some point that I could plug in to figure out A naught. Do I have any points I could use? Oh, wait a minute. I do. I'm going to pick a point to plug in. Write this down. That way you remember when you're doing your homework, because you have one just like this. The point I'm going to use is the middle guy. The 6, the 450. Don't necessarily have to use him. That's what I'm going to use. So my P of t is 450. My A naught, I don't know. But my T was 6. So this is really 6 over 6. Okay, solve it. 450 equals, 6 over 6, this is 1. Oh, that's why I picked that point, because I knew 6 over 6 was just 1. Now solve for A naught. Just divide by 3. So A naught is 150. Or A initial, your initial amount. So, sweet, we can write our equation now, or our function. P of t equals, what's your initial amount? Whatever it is, we started with 150 of it. What's happening to it? Oh, it's tripling. How often? Oh, about every 6 hours, or 6 days, or 6 years, or 6 months. That's awesome. Perfect. Now it says, okay then, smarty pants, how long would it, how much would you have after 24 hours? After 24 hours? Well, I got a formula now. I can plug it in. I started with 150. What's happening to it? Oh, it's tripling. How often? Oh, every 6 hours. And what are we interested in? Oh, 24 hours. So it's 150 times 3 to the 4th. That's 150 times 81, which is 1,150. I said that wrong. 12,150. My bad. I wish that was my bank account. Start with $150, and then in 12 hours, you'd have 12,150. That'd be awesome. Okay, one cute little rule here that I want to go over before this section's out is called the Rule of 72. And here's what it says. If a quantity is growing at some rate, some R percent, 5%, 6%, 7%, whatever it might be, per unit of time, years, months, days, whatever, then the doubling time, how long it takes to double, i.e. in the old formula, B would have been 2, is approximately, take 72 divided by R. That's true. It works. It's not exact. It's not a perfect science, but it's pretty darn close. Check out this example. A bacteria colony increases 8% per day. How long does it take the bacteria colony to double if it increases at 8% per day? Well, you take the rule of 72, since we're interested in doubling, that's the only time this applies, not tripling, quadrupling, anything. You take 72 divided by the percent, which is 8, which is 9. 9 days. About 9 days, give or take. It's going to be pretty close. Now note here, R is not allowed to be a decimal, not decimal form. I said that incorrectly. Not decimal form. So if R is given to you as in decimal form, then you got to switch it to percent form. Okay. In summary, here we go. All the formulas we've got so far. A of t equals initial amount times b to the t over k power. You'll usually use this formula when you're doubling something or tripling something or cutting in half, like the half-life or fourth life. You'll usually use this formula when you're working with something that's kind of sciencey, half-lives, things of this sort. Another formula, a cute little one, 72 divided by R percent. This gives you doubling time, not R squared. Silly Mr. Williams. R percent. This is only works for doubling time. So write that down. Only works for doubling time. The other formulas we've talked about this chapter. A of t equals original amount times 1 plus R to the t power. This is usually working with money, and it's always working with growth. Okay? And then finally, same exact formula, only it's 1 minus R to the t power. And that's working with decay, but it still usually involves money. So 1, 2, 3, 4 main formulas so far. We also kind of have a modified version of the first one, but the first one will get the job done. So just wanted to summarize that. I know that seeing all these formulas can be kind of overwhelming, especially when I'm asking you to recall them from time to time. So anyway, that's all I got for you. Hope you enjoy the rest of section 3. Talk to you later. I'm out.